Now let's look at the problem number 65 from chapter 5. Here we have two blocks connected by a rope of negligible mass being dragged by a horizontal force. Suppose F is equal 68 newtons and M1 is 12 kilogram, M2 is 18 kilogram, and the coefficient of kinetic friction between each block and surface is 0.1. In part A, you have to draw a free body diagram for each block, determine acceleration of the system, and finally you have to find the tension T. Okay, let me draw the boxes and draw free body diagram and find what is asking us to do. Now, so let me draw two boxes. Here we have first box, they're on rough surface. Here we have another box. So they're connected by a rope, which is tension. Then there is applied force, F, which is equal to 68 newtons. Here we have M1, have M2. M1 is equal 12 kilogram. Then here we have M2, which is equal to 18 kilogram. Now, coefficient of kinetic friction, mu k, is equal 0.1. Okay. Now, first of all, let's draw a free body diagram for each block. Now, in the first block, what we have? We have tension. We have mg. We have normal force. Then we have kinetic friction, which is always oppose the motion. Okay. Now, for the second block, what we have? We have applied force. We have M2G, by the way, this one is 2, okay? M2G, then we have tension, then we have kinetic friction, then finally we have normal force. Okay, now let's write down equation separately for two boxes. So for the first one, using the Newton's second law, we can say that sum of the forces is equal to M1A. Okay, so I'm writing equation for the first block. Okay, M1. Now, sum of the forces here. Now, if you define that the right side will be positive direction, then we can say that tension minus kinetic friction is equal to M1A. Now, kinetic friction of the M1 is equal to what? So tension minus mu k multiplied M1G, okay, which is equal to M1A. Now let's write down equation for the second block. For the second block, again, sum of the forces is equal to M2A. Okay. Now, sum of the forces in M2 block, which will be positive F applied minus tension minus kinetic friction of the second block, which is equal to M2A. Then from here, we can say that our applied force minus tension minus kinetic friction of the second mass or second block will be mu k M2G is equal M2A. Okay. Now, so far we got two equations, and by adding them, these two equations, what we will get. Now, if you add them, obviously you can see that your tensions will be cancelled out, right? So when you add them together, then you will get that the applied force minus mu k m1g minus mu k m2g is equal m1a plus m2a. Okay, then we can say that it's F minus mu k g m1 plus m2 divided by m1 plus m2, which is equal to acceleration. Now, if you plug the numbers, I already calculated, if you plug the numbers, then you should get for the acceleration, which is 1.29. Okay. Now, once you get the acceleration, you can use any of these two equations, okay, which is this one or that one, to find the tension. When you want to find the tension, try to use the equation which has less parameters, okay? So in this case, we can just use the first equation and plug the acceleration into here, and you can find the tension. So if you want to find the tension, then obviously you can say that tension is equal m1a plus mu k m1g. So the tension is equal, m1 is equal 12 multiplied 1.29 plus mu k is equal 0.1 multiplied 12 multiplied 9.8. So if you calculate this one, then you should get that your tension is equal to 27.2 newtons. Okay, this is how you solve such a problem.